Yeah, let's start by defining the term tensor and how it is used in the context of deep learning. So yeah, a tensor is a generalization of the concept of a vector, matrix, and scalar, and so forth. So for example, here's a scalar. A scalar is also, you can think of it as a rank 0 tensor. And an example of a scalar would be, for example, a real number. So or it could be also an integer, for example. So, but yeah, in the context of deep learning, we will usually work with real numbers most of the time, except maybe for the class labels where we have integers. So here, for example, that would be a scalar, a single value like 1.23. And a vector would be a rank 1 tensor. So you can see we're adding a dimension to it. Vector is a rank 1 tensor, and the matrix would be then a rank 2 tensor. So a vector is, a vector is like, you can think of it as a data container with n values in it. So that is usually something you would find in a linear algebra book. However, in our context here, in machine learning and deep learning contexts, we usually think of vectors as n times 1 dimensional. So it's still written the same way as you would find it in a linear algebra book, if you would write it like follows, where you have n elements, 1, 2, up to n. However, we will assume there's another dimension there. It's just 1, so there's one other dimension with no values in there. So it's essentially you can think of it as a very slim matrix, a matrix with only one column. And that is because, for certain computations, for convenience. And usually by default, I will denote the vector as a column vector. However, when I write a transpose, we will also sometimes use row vectors. So it's basically just a vector transposed, which is now a 1 times n dimensional vector. So regarding the matrix, here's a m times n dimensional matrix. So m is the number of rows, and n is here the number of columns. So that is just the general layout. So if n was 1, then we would have just this first column here, and you can then ignore this one. This would be then a column vector, like shown on the left-hand side here. This is just to lay the groundwork into the notation what a vector, the matrix, and a scalar are, and how that relates to the concept of a tensor. Now, in the context of deep learning and machine learning, we usually use for the data so-called design matrices. That's a common convention. If we use the letter X, then we usually refer to a design matrix, which is a n times m dimensional matrix. So on the previous slide, what I was writing on the previous slide was m times n dimensional. This is just something you would find in linear algebra textbook. The letters here, m and n, don't matter really, but there is a convention in machine learning and deep learning that most of the people use n for the data set size in terms of the number of training examples, and m is the number of features. So this is why I'm writing it as n times m, but it's also not super important. It's just a convention. And then, like I already talked about in the very first lecture, we will be using the subscript for the features. So that's the feature index, and here the superscript, that would be the training data point index or training example index. Say call it training example index. So if we have n training examples, then we would have the indices 1, 2, up to n. And here we would have up to m features. For example, in the iris dataset, we would have 150 training examples or data points and 4 features. So this would be m and this would be n. So on the previous slide we have seen rank 0 tensors and called them scalars, and we had for rank 1 tensors the word vector, and for rank 2 tensors we had the word matrix. Now for rank 3 tensor, how should we call it? Unfortunately, there is no special word for that. So usually, if we refer to a rank 3 tensor, we use the word 3D tensor, or sometimes, or often even, just tensor without the 3D here in front of it. So yeah, what is a 3D tensor then? A 3D tensor, you can think of it as a stack of matrices. So if each of the box here represents a matrix, a rank 2 tensor, then a 3D tensor would be, in the context of deep learning, yeah, like you can think of it like a stack of matrices, so multiple of these matrices stacked on top of each other. For example, here this would be a stack of P matrices, and each of the matrices here is m times n dimensional. So here we have m times n dimensional matrices, and we have P of such matrices here. And note here the m and n, they are really arbitrary. They don't refer to the features and training examples here. These are just some arbitrary letters. I was just using m and p because they are commonly used. But here, don't think of them as training examples or features. They're just generic terms here, or letters. So in practice, where we encounter these 3D tensors in deep learning is, for example, when we work with image data. So you can think of a single image here, like this cat, as a 3D tensor, where we have, for example, 3 color channels. The color channels R for red, G for green, and B for blue. And each of these color channels consists of pixel values. For example, this could be a 100 times 100 matrix containing the pixel values for each of the color channels. And combined, they are basically a 3D tensor. And that would be a case where we encounter a 3D tensor when we work with image data in deep learning. However, it doesn't stop there with 3D tensors. In practice, actually, we work with 4D tensors in deep learning because we have a training set consisting of multiple of such 3D images. So you can think of the 4D tensor here, if I go back, as a stack of multiple of these 3D tensors, basically. So stacking multiple of these. So here on the right hand side is just an example of the Cypher 10 dataset. So each of these is an RGB 3D tensor. And then also regarding the dimensionality, usually in deep learning we have the dimensionality of these 4D tensors as n, c, h, w, where n is the number of training examples, then c is the number of color channels, for example 3 in the case of RGB, so this is the color channels, and then h is the height of the image, and w is the width. So in that way, these last 3 dimensions here, they are basically our features, m. So in this case, we have c times h times w features, and n is still our training examples. So if we don't use deep learning, we would reshape that. We would reshape that into a matrix, a design matrix, which is n times m dimensional, where m is really c times h times w. All right, so but we are not working with color images yet. That would be something when we encounter convolutional networks where we talk about this. But I also plan to use a simpler model with color images where we explore then also this reshaping. So, but don't worry about it yet. Also, one more thing I wanted to say about tensors. You probably heard about the tool TensorFlow. So TensorFlow has the name Tensor in it. And here, in the context of these tools like TensorFlow or NumPy and PyTorch, the tensors really refer to the concept of a multi-dimensional array. So like a multi-dimensional array. You can think of it as a data structure or a computational data structure for storing or representing a tensor. So in mathematics we say tensor, but in practice when we do coding, these are essentially multi-dimensional arrays. And it just happens in TensorFlow. These multi-dimensional arrays are called tensor. In NumPy they are called ND array, where ND array stands for n-dimensional array, like multi-dimensional, n-dimensional. And in PyTorch they are also called tensor, but they are essentially all the same thing. So here's just an example. So here I'm creating or importing Torch, creating a tensor. And this tensor is a 2x3 matrix. So 2 rows, 3 columns. So this is really a 2x3 matrix. And then here what I'm doing is I'm using t.shape. And notice in NumPy there's also a t.shape. You probably know that. And this gives you the dimensions of the multi-dimensional array or tensor. So you can see here 2 and 3. This is the dimensionality, or in fact it's the numbers of values in each dimension. So this would be a 2-dimensional array because there are 2 dimensions. There's a row and a column dimension. So this would be the first and the second dimension. So the number of indices in shape would be the number of dimensions. And also conveniently you can also call ndim, which stands for the number of dimensions, and it will also return to 2. So ndim is essentially the same as calling leng in Python, leng on t.shape. So it's just a shortcut for doing that. So yeah, just wanted to briefly highlight tensors in the context of PyTorch, TensorFlow are the same as multi-dimensional arrays in NumPy. It's really the same concept. Yeah, and here is also just a nice summary from the Deep Learning with PyTorch book, where all the terms are here at one glance: scalar, vector, matrix, tensor, so in this case a 3D tensor, and here a higher dimensional tensor, so n-dimensional tensor. So in this case, you actually don't know how many dimensions, could be arbitrary. So it's also just making fun of it that this is something we can't visualize in our head anymore because, as humans, we can only really think of 3 dimensions. With the 4th dimension, it becomes all, some gobbledygook here. And this is just a short summary here of what we just discussed in the previous slides. And in the next video, I want to briefly talk about more about tensors in PyTorch. So if this was just a little bit short, I will talk more about this in the next video.